Alright, so we are going to jump straight into what we have to actually cover today, and we will be looking at sketching the following functions, showing the x and the y intercept, the turning point, and the axis of symmetry. This is a follow-up from a video that I did 8 days ago. The video that I did 8 days ago was basically on quadratic functions, and so I'm basically just going to do the game challenge that I had given to the grade 11 learners. This particular game challenge will be applicable to both grade 11s and grade 12s. So what I had asked them to do here was to sketch the following function, showing the x and the y intercepts, the turning point, and the axis of symmetry. So this is functions. Then secondly, they were supposed to give the domain and the range. And then also they were supposed to state which values of x is the function increasing and which values of x is the function decreasing. So we're going to look at each individual function. We're going to look at how do we sketch it, what are the steps that we follow whenever we are required to sketch a quadratic function on a separate axis, of course. So we've got f of x is equal to negative 3x² plus 27. And just so that we know, guys, this type of function here is your grade 10 function in the form ax² plus q. So this is a grade 10 function, this one here. F of x is equal to x² plus 7x plus 12. This is a grade 11 quadratic function. And so is this one as well. And so is this one as well. So the first one is a grade 10 type function, all right, quadratic function, parabola function. These last three are all grade 11 type quadratic functions, all right. And so in grade 10, you were supposed to know how to have learned how to sketch this function. That was your first exposure of the quadratic function. A quadratic function in the form y is equal to ax² plus q. That was basically grade 10. Here you have a quadratic function in the form y is equal to ax² plus bx plus c. Then here you have a quadratic function in the form y is equal to a into x minus p, the whole thing squared, plus q. So, and then the last one is also y is equal to a x² plus bx plus c. So it's very important to note the forms, all right? So these 1, 2, 3 forms, these last 3 forms are the forms that we get exposed to in the grade 11 syllabus. But this first form is the form that you get exposed to in the grade 10 syllabus, you know? So it's just something to note as a grade 10 and a grade 11 learner, that in quadratic functions, in as much as we know these 3 forms are the ones that we learn in grade 11, this form was a form that was learned in grade 10, but we need to still know this form, all right? So I'm going to then do the game challenge that I had given, like I said, 8 days ago, because I had started functions 8 days ago. And this lesson, particularly on the introduction of quadratic functions, you can find it on my YouTube channel, all right? It's called Maths is a Game, and you can find the full lesson there, all right? What you can actually anticipate, in actual fact, here is the sort of like the video lesson. It's the second video lesson from the top. So at the top you have grade 9 mathematics factorization part 1, and then you have class 11 maths grade quadratic functions, grade 11 functions. So this was the lesson from which I am actually going to do the game challenge, because I had done the lesson. It was 1 hour 51 minutes and sorts, and I think if you actually go through the entire video lesson from the beginning, then you can actually get the full scope and depth of the lesson that I covered, and the aspects and the concepts that I basically covered on that day. Because my intention today is to actually go through cover, you know, more of this particular content. and to actually do more. So yeah, graphing quadratic functions, that was the video lesson specifically. So let's go ahead and draw these functions. As it says sketch the following functions. The x and the y intercept you must show, and the turning point, as well as the AOS. By AOS they mean the axis of symmetry for each function. Then after that we are going to state the domain and the range of each individual function, and then after that we are going to show for which values of x is the function 1 increasing, and which values of x is the function decreasing. So let's take it one step at a time and go ahead. So whenever we are sketching a quadratic function, what method or approach do we use when sketching a quadratic function? Right? I hope we still have an idea of what method or approach do we take whenever we are sketching a quadratic function. So hopefully we all know that one, we use something called the dual intercept method. The dual intercept method. All right. So the dual intercept method, what does that mean? It means that we are going to find the y-intercept by letting what? X be equal to 0 for that particular function. Okay. So by letting x be equal to 0, what does that mean? So if we look at the function, it's f of x. F of x, guys, is just another way of saying y. Y stands for f of x. F of x means y. Y stands for f of x, and f of x means y. All right. So what we then do is, because we are letting x be equal to 0, in the place of x, we are going to substitute 0. So we're going to say f of 0 is equal to, everywhere where x is here, we're going to substitute 0. So that means negative 3, 0 squared plus 27. That gives us 0 plus 27, which means f of 0 is equal to 27. So in other words, the y-intercept, or at least here, the coordinates of the y-intercept are 0 and 27. Remember, when x, meaning x was 0, when we substituted into the function, we got y, which is 27. So these are the coordinates of the y-intercept. Please, comrades, these are the coordinates of the y-intercept. How did we get them? We let x be equal to 0. Why did we let x be equal to 0? Because we want to find out where does the function cut the y-axis. That's what we call the y-intercept. And so we got the coordinates. They are 0 and 27. Secondly, we are going to find the x-intercept. When we find the x-intercept, this is where we let who? We let y be equal to 0. So in other words, that's like saying f of x in its entirety is equal to 0. Remember, we said, what is f of x? F of x is y. And what is y? Y is also f of x. All right. So we are going to come here, substitute 0. So that means we are going to write down negative 3x squared plus 27. We are going to let f of x be equal to 0. So that means in the place of f of x, we are substituting 0 completely, because y is 0 when we are finding the x-intercept. So now we are going to solve for x. So hopefully we now know how to solve for x, because in term 1 grade 11 we did quadratic equations and we solved for x. So what do we do when we are required to solve for x? We can see this is a quadratic expression. The coefficient of the x squared is negative 3. So what we do is we divide each term by the highest common factor, which is negative 3. All right, we divide each term by negative 3. Yes, indeed, we could also transpose the 27, which could also work out. All right, okay, that gives us x squared minus 9 is equal to 0. This here is a quadratic expression. Which type of expression is it? It is the one whereby we can see we have a difference of what? of two perfect squares. So we can factorize that. How? By opening two brackets. All right, then of course to find the factors, we know that the square root of x squared is x, so therefore we write x and x for each bracket. Then the square root of 9 is 3. And then of course when we have a negative sign for our constant means that the signs of each term are different. So we have a positive and a negative. Then we write down our roots. Okay, x plus 3 into x minus 3, we remember that we apply the zero factor law, whereby we can equate each factor to 0. Then we write down our roots. Transpose the 3, we got negative 3, or x is equal to 3. Yes, I know that some people were thinking of something a bit different, in the sense that, like I think Gialeboche had said, she said that we would transpose the 27, positive 27, we'd get negative 27 on the right. That's fine. All right, but remember, we can only do that if there is a expression of degree 2 and there's a constant term. We can do that. Then what we do, then we would divide it by negative 3 here as well. We get x squared is equal to what? We get x squared is equal to positive 9. Then we would have taken the square root on both sides. But remember, when we take the square root for an equation, we must not forget to write plus minus. So therefore that would lead us to x is equal to plus minus 3. And that means basically x is equal to 3 or x is equal to negative 3. Two answers. Because remember, the squared suggests that we are supposed to have two solutions, or two x-intercepts, or two roots. Right? Okay, so that's fine. Therefore, our coordinates are negative 3 and 0, as well as 3 and 0. How do we know that? Because remember, we let y be equal to 0, so it should show the y is 0. Then our x values that we got occupy the place of x for our x coordinate respectively. Right? We are very close to basically being able to now sketch our graph, but what we are short of is our turning point. So when we have a function of this form, we know that this here is also the y-intercept is also our turning point. All right, this is what we learned in grade 10. This here, all right, our y-intercept is also our turning point. So that means, without even going ahead and calculating, the turning point is 0 and 27. All right, which would therefore mean that our axis of symmetry is the equation x is equal to 0. Right? In other words, it is the y-axis. That's our axis of symmetry. Okay, right? And remember as well, we need to know the shape of the graph. What dictates the shape of the graph? If the coefficient of the x squared term is negative, that would suggest that a is equal to negative 3, a is less than 0. That would mean we are expecting that our graph will be concave down. In other words, it will be a sad face because a is negative. Now we are ready to sketch our function. Very ready to sketch our function. So what we simply do when we are ready to sketch our function, this is the place in maths where you can actually use a pencil. We don't use a pen to sketch the function, we use a pencil, right? You can utilize your pencil now. You go and sketch your Cartesian plane, and all you need, guys, in your Cartesian plane is to mark the x and the y-intercept. So minus 3, 0 and 3 and 0. So we can mark, let's say the negative 3 and 0 is here, the positive 3 and 0 is there. This is just sort of like rough estimate. Okay, yeah, that's my x-intercept. Then your y-intercept or turning point, remember our y-intercept was 0 and 27. So 0 and 27, that means 0 and 27, okay, let's just say 27 is there, okay, so 0 and 27 would be there, okay. That is also our turning point. And then all we do, guys, we know that the turning happens here. It's very important. Okay, all we simply do, making sure, all right, that -3 is very evident and clear, the 3 is very evident and clear, and then the 27 is very evident and clear. Then you can mark and label your function. F of x is equal to -3x² plus 27. Any grade 10 learner should be able to comfortably sketch their function. Then, because we know that our axis of symmetry was supposed to be labeled, then we can write here x is equal to 0, because that is our equation. Our y-axis basically is our axis of symmetry. So this is our x-axis, this is our y-axis, and then we have 0. And the question, maybe someone will be asking me, so is it necessary to write all the values in between, like the 1, 2? No, guys. All that is important when you're sketching your function is making sure that we can see our x-intercept, you can see your y-intercept, the shape, all right, concave down, the smooth curve, guys, smooth curve, all right, concave down is there. And because they said we must show our axis of symmetry, I should see the equation of the axis of symmetry as well, right? So that's the sketch, done and dusted, all right? Okay, very simple when we are sketching a parabola function of grade 10 level, all right? Okay, we use the dual intercept method. We let x be equal to 0, substitute, get the y-intercept, write down the coordinates. We know that for the grade 10 function, our y-intercept is also the turning point, all right? Yeah, if you remember from grade 10 last year, we find the x-intercept, we let y be equal to 0, which means in the place of f of x, we are substituting 0 in its entirety. We then equate the expression to 0, we solve for x. Remember our rules for solving for x, and then we get our x values, our x-intercepts. We write the coordinates. Then, like I said, the turning point is the y-intercept. If you remember from grade 10, the equation of the axis of symmetry, this is our guide. The x value is the equation of the axis of symmetry, and then the shape of the function. Since a is equal to -3, it means a is less than 0, concave down. So then that's how we sketch our function, done and dusted. Let's move on to the next one. We are required to sketch the function of f of x is equal to x² plus 7x plus 12. Now this is grade 11, all right? Very important to know the distinction of the grades here. So important. So let's go ahead. Let's go and sketch this function. All right, so let's take note of the following. First and foremost, a is equal to 1. A is greater than 0. That means, what are we expecting? We are expecting a concave up function. It's very important to have these things, so that you know in your head what to expect. Begin with the end in mind. 2, we now need our y-intercept. Y-intercept means we let x be equal to 0. So that means f of 0 is equal to x². Remember, f of 0 is equal to, in the place of x, we substitute 0 plus 7 into 0 plus 12. All right? Remember, was it 7x plus 12? Yes. Yeah. So there we have it, right? Now, we have 12, which is f of 0. And remember, that means that our y-intercept, the coordinates of the y-intercept are what? Are 0 and 12. Those are the coordinates of the y-intercept. Okay? Yeah. Grade 11 function. Remember, I just want us to see the function. This is f of x is equal to x² plus 7x plus 12. All right, so we are moving together so far. 3, we find our x-intercept. That means we let y be equal to 0. So that means in the place of f of x, we are substituting in its entirety what? 0. So let's write x squared plus 7x plus 12, which is f of x. X squared plus 7x plus 12 is equal to what? 0. Have we seen this expression before? With basically now this expression equal to 0, the equation, are we familiar? Definitely. This is a quadratic expression. That means we do what? We can factorize this. All right. So any grade 9 learner would be able to factorize this, because even grade 9s in term 2, they learn how to factorize quadratic trinomials. Okay. So remember, what does plus mean? Plus means we have the same signs inside the bracket. According to who? According to the coefficient of the middle term. So we are the same according to the sign of the middle term. So we have positive and positive, that we know for sure. X squared is going to be formed by an x and an x. Then we want the factors of 12. Okay, factors of 12, which when we multiply give us 12, when we add gives us 7. That gives us 4 and 3. Then we use the 0 factor law, which then leads us to the roots. Now we are ready to write down our coordinates. Are we good? Hopefully we're so good, guys. I mean, okay, if anyone here is having any sort of like challenges, please do let me know in the comment section. But like this really, guys, is just so straightforward. So straightforward. You're given the function, you use a, the coefficient of x squared, to determine the shape of the function. There it is. Since a is equal to 1, a is greater than 0, that means smiley face. We find the y-intercept. By y-intercept, we let x be equal to 0. In the place of x, we substitute 0. 0 squared plus 7 times 0 plus 12. We use brackets to substitute. Then we know that this gives us 12. F of 0 is 12. That means the coordinates of the y-intercept are 0, because x was 0. 12, which is y, which is 12. Then we find the x-intercept. We let y be equal to 0. In the place of f of x, we substitute 0. We then take the expression x squared plus 7x plus 12 equated to 0. We factorize, because we learned in term 1 how to factorize as grade 11s. We should be affluent now, masters of factorization. Apply the 0 factor law, find the roots, write the coordinates. X-intercepts, good. Now what do we need now? Turning point. When our function is in this particular form, the turning point can be found using a formula which we refer to as x is equal to minus b over 2a. This is how we find the x coordinate of the turning point. This is also how we are able to get the equation of the axis of symmetry. Two things: the x coordinate of the turning point as well as the equation of the axis of symmetry is found by using x is equal to minus b over 2a. This is a formula that all of you should know, because whenever your function, your quadratic function, is in the form of ax squared plus bx plus c, this is how you will be able to determine your axis of symmetry, your equation of the axis of symmetry, as well as your x coordinate of the turning point. This is the way. We don't want to be going ahead and completing the square of the expression and then reading from the function the x coordinate of the turning point. When it's in this form, here's your formula. So let's go ahead and do that. X is equal to minus b over 2a. So we go to the standard form of the quadratic function. What is our value for a? A is equal to 1. Coefficient of the x squared term. What is the value of b? Positive 7. Coefficient of the x term. By coefficient, I mean the number that is multiplied to the variable. Okay, so positive 7. B is positive 7. What is the value of c? I mean, obviously, we know most that c is usually something we would have done as well. C is equal to 12. So in the formula, we don't need c, we just need b and a. So let's go ahead and substitute. Negative is already in the formula. B 7 2a. Answer -7/2. This is the x value of the turning point as well as the equation of the axis of symmetry. So if you are basically going to check out in your calculator so that you know in decimal form what is the value, this is like 3.5. In other words, it's 3,5. It's -3,5. So when you use your decimal, it's not so much that you basically want to write your answer in decimal form. No, this will help you to be able to sort of like know where about in the Cartesian plane should you place this, because this should be your axis of symmetry as well as your x-coordinate of the turning point. This is like midway for your parabola. But remember, for your turning point, you must get the x-coordinate, but also you must get the y value of the turning point, because this sort of function here is not going to be symmetrical along the y-axis. This one has moved from the y-axis, all right, left and right. This is the new thing about our quadratic functions in grade 11. They move from left to right. You know, they don't, they are not limited symmetrical along the y-axis. They move, all right, left and right. Unlike grade 10 functions where the movement was limited, you know, up and down alone. Yeah, so now we are going to actually check the y-coordinate. We are going to take this x value, f of -72, we are going to go and substitute it into the function so that we can get the y-coordinate of the turning point. So here we go, in the place of x, -7/2, followed by a squared, plus, in the place of x, 7 into -7/2, plus what? Plus 12. Then what's easy, guys, for you to just grab your calculator and get the answer as a fraction. You don't have to, you know, step by step try and get the values and all of that stuff. Though you can do that, but can someone who has a calculator, okay, because I don't have one at my disposal at the moment, so I need you guys to help me out here. So I need someone to actually punch this in and then tell me what do they get. All right, the fraction answer first, obviously according to your calculator, and then after that, please also let me know the decimal value so that we can know roughly where on the Cartesian plane this y value is. So I'm depending highly on you guys. I don't have my calculator on me right now. Or must I go grab it? Because I may need it. Right, I think let me go grab it. You know, sometimes I've learned certain things by sad experience. Let me grab it. Okay, let's go. So we have this, so that's this -7/2. Then we follow that with the bracket, we square it, we say +7, we bracket -7/2, we bracket it, +12. Okay, I'm glad I actually used my own calculator because I think it would have taken a while. Still not getting any response. Okay, -1/4 would be my answer, but just so that I know what I'm dealing with, it's -0.25. Okay, obviously I'm going to write the fraction -1/4. Okay, that's my f -7/2. So that means my coordinates are -7/2 and -1/4. These are the coordinates of the turning point. Okay, right, I'm about ready to actually sketch my function. Okay, I've done the groundwork. I'm now ready to sketch my function. I know the shape of the function because my a was positive. I know it's concave up. I found my y-intercept by letting x be equal to 0. These are the coordinates of the y-intercept. Found my x-intercept. These are the coordinates of the x-intercept because I let y be equal to 0. My turning point, I used the magic formula, x is equal to minus b over 2a, right? Used my a and my b value from my coefficient of the x squared and the x term to basically get my x coordinate of the turning point. And then I took my x coordinate of the turning point, substituted it back into the function so that I can get the corresponding y value of my turning point, which is negative 1 over 4. There my coordinates are negative 7 over 2 and a negative 1/4. Now I can go ahead and go to my Cartesian plane and sketch using these respective points. I also know what the equation of the axis of symmetry is. It's negative 7 over 2, which is roughly negative 3,5. So let's go. Here was my x of my y-axis and my x-axis, so y and my x, right? So let's remember, what did I have? My x coordinate. There's something here. What's happening here? Oh, something went wrong. Okay, sure. Okay, guys, what an error I made there. Oh no, it's not. Oh, okay, it's not an error. It's just that there's something here that I don't quite understand. Okay, let's just go back a bit here. Just make sure that everything is fine. F of x is equal to x squared plus 7x. Yes. Uzubenat, you could get the. Could you get the x-intercept by completing a square? Yeah, but Uzubenati, why are you complicating your life? Okay, x-intercept, you let y be equal to 0. Okay, that's it. Yeah. Unless you are saying, can you get the x coordinate of the turning point by completing the square of the expression? Yes, you can get the x coordinate of the turning point by completing the square. Right, I think that's what you were asking, not can you get the x-intercept. Remember, the x-intercept is where the graph cuts the x-axis. That's where you let y be equal to 0. So you're not asking, can you get the x-intercept by completing the square of the expression. I'm sure you were asking, can you get the x-coordinate of the turning point by completing the square of the expression? Yes, you can. But why do you want to complicate your life like that when you have a formula? Okay. Yeah. So don't complicate your life. Yeah, here where I stay, there's a lot of noise. I'm sorry for the background noise. There's a lot of background noise. Okay, because there's students here. Yeah, and they you know how Saturday nights. So hopefully you guys won't be like that when you leave your homes, leave your nests at home, and you become varsity students. Because there's a lot of varsity students here that are just messing up their. I don't know, they are living below the standard I think maybe most of their families are anticipating, and they butcher their lives here and they just get up involved in a lot of nonsense. So yeah, and I don't know if their academic futures can really materialize if you're kind of living a lifestyle that you are. But nonetheless, let's come back here. Sorry guys, I just want to check here. So we did let a be equal to 1, the coefficient of x squared. A is positive. That means our graph will be concave up. We expect that, right? Okay, smiley face. Y-intercept, we let x be equal to 0. Our substitution, was it spot on? 0 squared plus 7 times 0 plus 12. So f0 is equal to 12. Our coordinates are 0 and 12. So this is 100% spot on. Then our x-intercept. X-intercept, we let what? We let y be equal to 0. In the place of f of x, we let y be equal to 0. So when we solve, let's just check if everything is fine here. X squared plus 7x plus 12. Our factors, 4 times 3 does give us 12. 4 plus 3 does give us 7. So that's fine. Our x coordinates are 100% spot on. Let's just verify again here. X is equal to minus b over 2a. Minus the b. The b is 7, right? But we say negative 7 over what? Over 2, right? 2, and then the a is 1. 2 times 1 is 2. What's 7 divided by 2? 7 divided by 2, is it giving me, yeah, okay, it's negative 3.5, right? Is that correct? Yeah. It's negative 3.5. Okay, so are we confirming, guys? Is everything fine? Are we confirming as well from our sides? Okay, all right. And then we substitute the x value. We get negative 1/4. So these are the coordinates of the turning point. So far we are good, right? Okay. So let's go and sketch now. So our x value, okay, so negative 4, okay, and let's just say this is negative 3, okay, and then negative 3,5 will be in between. That will be there, smack bang in the middle. The corresponding y value is negative 1/4. Okay, so let's just say negative 1/4 for y. Okay, let's just say that's here. So negative 3,5, negative 1/4 where the 2 meet. Let's just say that's there. Okay, and then our y-intercept was positive 12. Let's say positive 12 where the graph cuts the y-axis. Let's say that's there. Okay, so we know where we are turning. We are turning here. Okay, we know where we are turning. All right, maybe let's just bring down the negative 1/4 so that it's here a bit here, so that our turning is a bit further away. All right, so yeah, I hope you guys get the point though. So if we are coming down here, then we are turning there. You see? Yeah. So that basically would be how our sketch would be like here. Okay. So sorry, I don't have a rubber right now. So it's just gonna erase that part, this part, because yeah. And this is basically, we just reveal those parts that are important here. Then what I would do, because I said indicate the axis of symmetry, we would then draw this line, this axis of symmetry here, and then we would label, right, that's x is equal to negative 7/2. Remember, that's negative 7/2. Then I would write down my coordinates of the turning point, negative 7/2 and 1/4 and negative 1/4. All right, my x, that's negative 3, my x as well, this side is 4, and that's 12. Very important to indicate. Okay, yes, of course the x-axis scale is horrendous, for sure. All right, because yeah, it is horrendous, but you can use a x-axis scale that is appropriate, of course. All right, and all that we are requiring our learners to do here in this particular question, we are requiring them to just indicate, to show. So please do use a x-axis scale that is amazing, Justin, severe. That's awesome. Mine is definitely horrendous because, like I said, I'm doing it rough. Okay, but do make sure that, so your x-intercept, your x-intercepts, all right, use a x-axis scale that is better, you know, be better than me, definitely, all right. And then you can go ahead and label the function because it was actually f of x is equal to x² plus 7x plus 12. Okay, what I'm trying to emphasize here is that your x-intercept, you know, those are the things that just need to be there. Your x-intercept, then obviously your y-intercept, I need to see that, all right? All the other values, like, you know, they are not of importance. What you need to see is you need to see the main things of your sketch. The shape, all right, which is important because you get a mark for your shape. Your x-intercept, you get a mark for your x-intercept. They must be visible, -4, -3. Your y-intercept, that must be visible. You get a mark for that. And then obviously you must write your coordinates of the turning point. I usually insist that you write your axis of symmetry so that you can know where the graph is symmetrical as well. So, I mean, those are important things that need to be in place in order for examiners to be able to award you your marks. So your x-intercept, that must be visible. Your y-intercept, your x-intercepts, they must be visible. Your shape, your coordinates of the turning point. Very critical, those things, all right? And those all come from your calculations, making sure that your calculations are on point, all right? So that's important. Then the last thing I want to do is number 3. I'm not going to do this one, all right, because this is simply a repetition of number 2. All right, I just want to look at these different types so that you guys can appreciate this one, because you see this one, grade 10, is different from this one, grade 11. Here you could see that this one and this one, they are different in the sense that here your turning point is your y-intercept, but here your y-intercept and your turning point are different. Here, number 3, this one, grade 11, guys, this here, we call this form. It's still quadratic function, parabola, but we call it the turning point form. Okay, the turning point form. So we are going to actually look at it and see how do we go about sketching the function when we are given the function in turning point form. So Money Magnet, yes, I do grade 9. Okay, my YouTube channel as well, I've uploaded lessons on grade 9 that I've done so far. You can check out the link in my bio and you can check that out, what I've done so far with the grade 9s. So guys, I'm gonna start using the early mornings to do live lessons now because yeah, I'm having problems at night, and sometimes during the day I'm so busy. So the point is to sleep early, wake up around about 2-ish, 3-ish, and then have live lessons. Then I'll upload, obviously I'll upload what I've done and I've covered onto my YouTube channel for those who may have missed it, who can't really acclimatize to the time. Okay, and I'm gonna try and do different grades, different mornings. So yeah, so this is the function g of x is equal to negative into x minus 2 the whole thing squared plus 1. So this is your turning point form. Turning point form is y is equal to a into x minus p the whole thing squared plus q. So same thing here. First things first, a value. Where's the a? Here is the a. The a value is negative. Negative what? -1. So we start there. A is equal to -1. That means a is greater than 0. So what am I mean, a is less than 0. Why am I saying a is greater than 0? What nonsense am I saying here in the morning? A is less than 0. That means I'm expecting a concave down function. Okay, and as such, that is the sketch I'm expecting. If the value here was positive, then obviously it would be concave up. All right. 2. Let's find the turning point. Yeah, turning point is very easy. What's nice is that the turning point, if you remember in term 1, you guys did how to complete the square of a quadratic expression, and you write your function in this form. Then you would basically be asked, what is your minimum or your maximum value? Now, I'm sure you can see that when a is negative, that speaks to the fact that we are going to get a maximum. But remember, when a is positive, that would have meant we would get a minimum value. What is the minimum value? We know that we would know that the minimum value or the maximum value is positive 1. So in this case, the maximum value would be positive 1. Then they would also ask, what is the x value that gives you the maximum? Then you would find the inverse of this negative 2, which means x is equal to 2 in order to get the maximum value, that is positive 1. Now, the turning point is simply the inverse of this x value as well as the q value as it is. So our turning point, guys, what is the inverse of negative 2? Maybe in the comment section you guys can let me know, what is the inverse of negative 2? If I was to take the x minus 2 and equate it to 0, x is equal to what as the inverse of negative 2? X is equal to positive 2. So that means the inverse of negative 2 is positive 2. My x-coordinate of the turning point can be read from the expression. The inverse of negative 2 is positive 2. So that means the x-coordinate of the turning point is 2. Okay? Simply like that. Here we don't have to use a formula. If our function is in this form, we call this the turning point form. The y is equal to a into x minus p, the whole thing squared plus q. The inverse of negative p is the x-coordinate of the turning point. The x value in this case that gives me a maximum is the x-coordinate of the turning point. So x is equal to 2. That's how you get the x-coordinate of the turning point. Maybe someone else is sitting and asking, what if, sir, it was x plus 2 in the bracket? What would be the x-coordinate of the turning point? If the bracket was x plus 2, then the x-coordinate of the turning point would be x is equal to negative 2. But because here x is minus 2, it means the x-coordinate of the turning point is x is equal to positive 2. I hope we are together there. Then, so I hope you see what I did here. This here is my x-coordinate of the turning point. Simply take x minus 2, equate it to 0, solve for x. That's the x-coordinate of the turning point. You could read it. X minus 2, what's the inverse of negative 2? It's positive 2. X is equal to 2 for your x-coordinate of the turning point. Then what is the y value of the turning point? It is the q value as it is. So you take this positive 1 as it is. That means the y-coordinate of the turning point is 1 as it is. Are you with me? Guys, I'm not moving here until I can get confirmation that you guys understand how to write the turning point of your quadratic function when it's in this form. Do we all get it? How to get the x-coordinate and the y-coordinate of the turning point from this form. Are we all clear on how to get the x-coordinate and the y-coordinate of the turning point? It is the x value, the inverse of negative 2. That's positive 2. Or you can take the expression, equate to 0 and solve. Alright, you will always get the x-coordinate of the turning point by doing that. The y-coordinate of the turning point is simply the value of q. This constant as it is the y-coordinate of the turning point. It's positive 1, so I write positive 1. If it was negative 3, I would write negative 3. If it was positive 7, I would write positive 7. Okay, let's move on. Then I find my x-intercept, meaning I let y be equal to 0. So let's go ahead and find my y-intercept, which means in the place of g of x, I'm going to substitute 0. So I'm going to write negative into x minus 2. The whole thing squared plus 1 is equal to 0. Then let's solve. X squared minus 4x plus 4. Remember here, you open the two brackets. Okay, very important. We open two brackets because some people say x squared plus 4, which is wrong. So you open two brackets of x minus 2, then you FOIL x times x, x squared, x minus 2 minus 2x, minus 2 times x minus 2x, minus 2x minus 2x gives you negative 4x, and then negative 2 times negative 2 gives you positive 4. Then the plus 1 is there outside the bracket. There's a negative awaiting to be distributed. You take the negative, you distribute it. Negative x squared plus 4x minus 4 plus 1 equal to 0. Then you add like terms. Coefficient of x squared is a negative value. You divide by negative throughout. That gives you, okay, I just want to show this step. You're going to divide both sides by negative 1. So this negative divided by negative gives you x squared. Positive divided by negative gives you negative 4x. Negative divided by negative gives you positive 3 is equal to, obviously, 0 divided by negative is 0. Then we factorize. Positive means same signs inside the bracket. According to who? According to the negative sign. So we have negative, negative. Factors of 3, 3 and 1. This addition of negative 3 and negative 1 gives me negative 4, 100%. The multiplication gives me positive 3, 100. X plus 3 is equal to 0, or x minus 3, sorry, is equal to 0. Okay, I usually hate when learners do this, so I'm going to scratch everything out, because sometimes when you do that thing, it's almost as if now you are emphasizing, you're trying to emphasize that it's minus, but then it appears like plus, and then I can mark you wrong in a test. So rather, or in an exercise, so rather do this, rewrite it so that I can see what you meant. So x minus 3 is equal to 0, or x minus 1 is equal to 0. So x is equal to 3, or x is equal to 1. My coordinates, 3 and 0, 1 and 0. Okay, that was my x-intercept, letting y be equal to 0. 4. Find your y-intercept. Let x be equal to 0. If we let x be equal to 0, that means g0 is equal to negative into 0 minus 2, the whole thing squared, plus 1. So just to answer your question, about do you do engineering mathematics through applications? No. Guys, I'm a high school teacher, so this is me helping high school students. All right. You may find that maybe if you're going to college, there are certain things that may overlap. So of course, if those things overlap and there's things that you cover in your respective courses, then you'll actually relate to them. But does that mean I have the expertise to teach in that level? No. Okay, so I would advise for you guys to find someone relevant to be able to do that. So G0, guys, here, right, is equal to negative 3. So that means my y-intercept is actually 0 and negative 3. I think we are ready to sketch now, guys. Do we have everything that we need? Yes, we do. All right. Remember, from this turning point, we can write our equation of the axis of symmetry, because it's always the x coordinate of the turning point that is the axis of symmetry. Equation of the axis of symmetry. So yeah, there we have it. Okay. Yeah. So your term 1 work is actually now being put into practical use. Now imagine if you are a learner that's still struggling with solving for x, algebraic manipulation, FOIL, addition of like terms, signs, simplification, solving for x, then that means that you are going to be consistently making errors here, all right, on your way to sketching a function. And that is very, very wicked. It's very, very wicked on yourself. It's not fair, all right? Okay. So now I think we are ready to sketch the function. We have everything that we need. to sketch the function. We needed the x-intercept. We know our shape. We know it's going to be concave down, so we know what to expect there. Turning point we have, it's 2 and 1. All right. So 2 and 1. Okay, 2 and 1. Then our x-intercept, 1 and 3. 1 and 3. Okay. Okay, so let's go 2 and 1. Where x is 2, so go to our Cartesian plane. Where x is 2, it's here. Where y is 1, where do the two meet? We meet here. Okay, yeah. Then our x-intercept, 1 and 3. Our y-intercept, 0 and negative 3. Where's 0 and negative 3? 0 and negative 3, let's just say 0 and negative 3 are here. Okay, yeah. So here, guys, here is the thing. Here's the sketch. We turn. Okay, let's try and bring our 3 a bit closer. Okay, let's remove that. Okay. Okay. Axis of symmetry. So there's our negative 3. Nice. That's the y-intercept. Remember, that was the y-intercept. We got 0 and negative 3. X-intercept 1. The other x-intercept, that's 3. Okay, and then our axis of symmetry, which is x is equal to 2. Then our turning point, just label our turning point here. We have 2 and 1. 2 and 1. That's our TP. And look, our curve is nice and sweet, right? Yeah. Now let's go back and try and answer the additional questions there. All right, I think I'm going to now allow at least people, we know how to sketch a quadratic function. Doesn't matter what way it appears. Okay, sometimes they try and be a bit tricky, you know, where they may say f minus 12, f of x minus 12, for instance, is equal to x² plus 7x. Now it's a matter of you being able to get it first into its standard form. You simplify first, you get things into their standard form, then you can work. All right, so yeah, there's one of 3 forms that a quadratic function can be presented as. It's this form, grade 10, this form, grade 11. These 2 forms, this is called the quadratic form, and then this is called the turning point form. All right. And you saw how I basically am able to get my answer. The next question that they ask is, they say give the domain and the range of each function. Okay, guys, what do we mean by domain and range? All right, so domain simply means, when we say domain, we are saying the x values where the function exists. The values of x. It's like the set of real numbers where the function exists. That's what you mean. All right. Which values of x do we see the function existing? All right. So let's look at this one. And when we look at the domain, we usually look at it from left to right. What's nice is that here we have the x-axis. This is x values basically, right? So when we look at the domain, we are looking at the function from left to right. Where does the function exist from left to right? Now, because we can see that there's arrows here, it means that the function is not restricted. This is an unrestricted parabola. From left to right, this function has no beginning, it has no end. I repeat, the end might be near upon 7th journey, but here, this parabola function, this one has no beginning, it has no end. From left to right, this function has no beginning, it has no end, right? Because this function will continue infinitely, which means we'll always see the function represented from left, and then this function will turn there, but it will continue, which means for each x value, the function will always be represented somewhere. Are you with me? So that means if we are looking at the domain of an unrestricted parabola function, for this first one, f of x is equal to negative 3x plus 27, what would we say is the domain? So simply put, we say that the domain, is x is an element of real numbers. X is an element of real numbers, all right? X is an element of real numbers. Are we together? So the domain of this parabola function is x is an element of real numbers. Or if you don't want to write it that way, you could say x is an element of negative infinity to positive infinity, and then you use open brackets to represent that. So these are two ways of writing the domain of a parabola function that is unrestricted, because remember, domain means possible x values where the function exists. So you are looking at the function from left all the way to the right. So what are the possible x values where the function exists from left to right? It exists from negative infinity to positive infinity. Or in other words, we could say x is an element of every single real number that you can imagine. Every real value of x, you will see the function existing. There is no x value where you will not see the function existing, all right, from left to right, because those are the x values. From left to right, we are reading x values from left to right. Then range. What is range? Range simply refers to the possible y values where the function exists. So if you are looking at range, you are looking at the function from the bottom to the top, from the bottom to the top, from the bottom, your lowest y value, to the top, your biggest y value. Where does the function exist? From the bottom to the top, where does the function actually exist? So we are going to look at this practically. Remember this parabola function, okay, when we looked at the shape, it was concave down, which means this function has a maximum value. What is the maximum value of this function? For this function, we can see that the maximum value, which is the y value that is the maximum, is 27. Okay, this function exists here at y is equal to 27, but it exists everywhere below this line. This function does not exist above this line. This function will exist everywhere below the maximum value, which is 27, where y is 27. So it exists at that y is equal to 27, and it exists everywhere below this y is equal to 27. So what can we say? If the function exists at 27, it means that the function is equal to 27. But if the function exists as well below this line, then it means the function also exists less than 27. Okay, so we write the range and we say y is less than or equal to 27. In other words, the function, this less than means below. The less than means below, where y is below 27. Y is less than 27, but it also means y is equal to 27. Okay, so hopefully we are together. I will try and compile one. Because the honest reality is that it's very hard for me to compile a timetable. Why? Because one, I have a lot of network issues lately. All right. So when I say I'm going to come on at a specific time, sometimes my network just doesn't allow me to log on. Two, my schedule at the moment is really not a conducive one, because it's very hard for me to have lessons on a daily basis. It's very hard sometimes for me to even have a lesson because I am so busy. So it's very difficult for me to have a schedule. Hence, I'm relying on the fact that if I do a lesson, whether people join or not, I'm also going to always upload the lessons onto the YouTube channel. So on my YouTube channel, I've uploaded all the lessons that I've done to this point. During the holiday, whatever I did is on the YouTube channel. The link is in my bio. You can check out the link in the bio. I've also made it a point to divide the work into playlists. So I have a grade 11 term 2 playlist for Euclidean geometry. It's there. The lessons that I've done, that I've covered here on the platform, they are there. Also, I have a grade 9 playlist for the grade 9s. The playlist is there. Grade 10 playlist, term 2 for the grade 10s. The playlist is there. All the lessons that I've done so far, I've uploaded them onto the YouTube channel. So I'll be uploading the lessons on the YouTube channel, and then I'll also try as much as I can to indicate the date in which I did that lesson, and the lesson and the order. So I'm trying, guys. It's very difficult for me to come up with a schedule. I'm thinking now as well that I think one of the things I'll be doing is utilizing the mornings now as well. So I'll be try every day to be up by 3, and then I'll see if I can make a schedule based on that. Maybe that's the only feasible schedule that I can actually make, for sure. Yeah, the thing is, I am not prepared to actually assist with calculus at the moment, but I get your point, and maybe, let's say tomorrow or the day after, I'll see if I can't have a morning where I can just do calculus alone. Okay, that's fine. Okay, is there something specific, Chia, that you want to be assisted with in calculus? Okay, all right. So yeah, so the range of this function, though, is y is less than or equal to 27. That's the point I wanted to make. Y is less than or equal to 27. Or you could write the range in interval notation and say y is an element. Now, I want you to be clear. No problem, Chi. I can do the basics, no problem. So y is an element. Let's have a date tomorrow. I will actually wake up at 3:30 tomorrow and do calculus for you. So y is an element. Now, y is an element of, so remember, what did I say? Range is written from the bottom up, from the smallest. If you are going to write in interval notation, you need to always start from the lowest thing to the biggest thing. You see, when we wrote our domain, we said we can write it in interval notation, which means from small to big. Smallest, negative infinity from the left. That's why I say from left to right, because at the left you have your smallest x values, on the right you have your biggest x values. So from x is an element of negative infinity to positive infinity. If you write your range for this function, you are looking from the bottom to the top. So you can say y is an element of what? You say open brackets, negative infinity, because that's where we are coming from, negative infinity to where? To 27, but you use square brackets. Why do we use square brackets? Because 27 is included. Okay, it's included as an y value where the function does exist. So you have two options. When a function is concave down, if the function is unrestricted, the domain will always be x is an element of R. You can write it that way, the domain. Or if you don't want to write it as x an element of R, you can say x is an element of open brackets, negative infinity to positive infinity, close open bracket. You open your brackets, because negative infinity and positive infinity are basically concepts that show that numbers go on forever. Then your range. If you have a concave down function, obviously you can either write your range as y is less than or equal to whatever the turning point value is, whatever your y coordinate of the turning point is. You say y is less than, in other words, y is below the maximum value, but also equal because the function also exists there at 27. So you can either write it your answer in inequality form like this, or you can say y is an element of, and then you know from the bottom negative infinity to the top 27, but negative infinity open brackets to 27 close brackets. Okay, that's concave down. That is the domain and the range. Let's go and look at this function. We're also supposed to write the domain and the range for this function. What about this one? This one is concave up. What is our y value of the turning point? It's negative 1/4. Okay, so let's start with domain first though, because we know domain is possible x values. What will be the domain for this function? Once again, this is an unrestricted function, which means it will exist from left to right all the way through. There's nowhere where the function will not exist from left to right. So that means our domain is x is an element of real numbers. Please guys, the arrows indicate that the function is unrestricted. There's no place from left to right where the function will not exist. Okay, this continuity shows that the function exists for every x value. It will continue forever and ever. From left to right, the function will exist everywhere. That's why x is an element of real numbers. We can write the domain like that. Or you can say, if you don't want to write it this way, you can say x is an element of open brackets negative infinity to positive infinity. Okay. What about the range? Possible y values where the function exists. We are going to the y coordinate of the turning point. It's negative a quarter. The function exists there. Remember, domain range, we look from the bottom up. From the bottom up. So there's two ways you can write your range. You can say y. Now let's look at the function. It exists at negative 1/4 where the function turns. But where else? It also exists above the y value or the minimum value, which is negative 1/4. So how do I write that down? I say y is greater than or equal to negative a quarter. That is my range. That is my range. That is my range. Okay, that is my range. And it's as simple and as beautiful as that. Y, like I said, is what? Is greater than or equal to the y coordinate of the turning point, which is negative 1/4. Okay, yeah. So do you see when the function is concave up, smiley face, y is greater than, the function is above negative 1/4, but also there at negative 1/4. So above and equal to negative 1/4. Okay, or you could write your range in interval notation. From the bottom is what? Close bracket, negative 1/4 to where? All the way to what? To positive infinity. Okay, so you must decide which way you want to write your answer. You want to write it in inequality form, or do you want to write it in interval notation? You must decide. Me, I'm exposing you to both so that you can choose. All right, yeah. Okay, so I'm sure the only thing you can see is consistent is your domain, whether it's concave down, but if it's unrestricted, or concave up and it's unrestricted, then our domain is always x is an element of R. Okay, or you can say x is an element of negative infinity to what? To positive infinity. The range, on the other hand, when it's concave down, we can say y is less than or equal to the maximum value. when it's concave down. But when it's concave up, we say y is greater than or equal to the minimum value, which is -1/4. Or you can choose to write in interval notation from -infinity to 27, whereas here it's from -1/4 to infinity, because it's from bottom up, bottom up, bottom up. Range is written from bottom up, bottom up, bottom up. Range is written from bottom up, bottom up, bottom up. Range is written from bottom up, whereas domain is written from left to right, left to right, left to right. Domain is written from left to right, left to right, left to right. So range is written from bottom up, bottom up, bottom up, whereas domain is written from left to right, left to right, left to right. You need to decide interval notation or inequality form. You must decide. Let's go to the last one. Domain and range for this function. This one, the domain first and foremost. Function is also unrestricted. Okay, arrows on either end, unrestricted function. So the domain then here is what? What would we write as the domain, people? Comment section. I'm waiting for you to go crazy. Tell me what the domain of this function is. Or people are still sleeping. I can just see some people sitting, lying in their beds. They're just double tapping on the screen. Yeah, Snack on my side, thank you so much. At least you are here. Yeah, but let's not forget x is an element, -infinity, open brackets, to +infinity, open brackets. That's one way of writing the answer. Or you could say, if you wanted to, simply put x as an element of real numbers. Okay, Pumzani, thank you so much as well. What about the range? What would be the range here? Range? Okay, Chia says y is less than 1. So Chia, you're looking at the right place, definitely. The y coordinate of the turning point, the maximum. Okay, but is it just only y is less than 1? Or is there more to it? Okay, because that's incomplete. That's part of the answer. Y is definitely less than 1. But remember, the function also exists at 1. Thank you so much, Chia. Y is less than or equal to 1. Very important. Okay, yeah, because the function exists below this y value. So below means less than. Okay, so y is less than or equal to 1. Or you could write it in interval notation and say y is an element from bottom up. So that would mean from -infinity to 1 square bracket. Okay, hopefully guys we're getting the point. Then the last question that was asked here is, for which values of x is the function increasing? Now, we need to be very clear here. When we say the function is increasing, let's check what is happening. Basically, okay, hopefully we know that this function here, this side, if it's concave down, it increases here, we are increasing here. We turn stationary point, we decrease here. So we increase here, we decrease there. We increase, decrease, increase. So here, what's happening this side? So when we are concave down, we increase this side. This side, we decrease. Maybe people are asking or wondering, how do we know we are increasing and we are decreasing? Remember here, when x is increasing from left to right, we are reading things from left to right. So from left to right, we are increasing. As x increases, what's happening to y? As we are moving from left to right, y is also doing what? Increasing. So that's why we talk about increase here, is because as x increases, y is also increasing. Okay, so for instance here, we have -3 and 0. But if you were to go on to the next value, let's say -4, you would find that the y value is more than this y value that you had at -3. As you continue, you see you are increasing from -3. At 0, what's happening to y? Y is actually 27. So that means we are increasing from left to right. But we are only increasing from -infinity to here. That's where we are increasing. So that's why we say this side we are increasing. But this side, what's happening? If you are noticing here, from here to there, as x increases, y is doing what? It is decreasing. So we say this side is decreasing. So we increase, all right? Axis of symmetry basically divides our increase and decrease. So this axis of symmetry is dividing this side to the increasing side and this side to the decreasing side. Okay, let's look at when the function is smiley face or concave up. The axis of symmetry is dividing our function into this side is what's happening to this side. What's happening this side? As x increases, what's happening to y this side of the axis of symmetry? Talking about the left hand side of the axis of symmetry. As x is increasing, what's happening to y? And what can you say about the function? Is it increasing on the left or is it decreasing on the left? So as x is increasing, something else is happening to y. As x increases on this side of the axis of symmetry, as x is increasing here, y is actually decreasing. Okay, y is decreasing. So here we talk about a decrease, but this side we talk about an increase. Guys, this is always true for our functions, parabola function. Okay, if it's a sad face, then it increases on this side, it decreases on this side. But if it's a happy face, it's decreasing on this side, it's increasing on this side. Okay, and so the question usually asks, for which value of x is the function increasing? For which value of x is the function decreasing? That's what they usually ask. For which value of x is the function increasing? For which value of x is the function decreasing? Okay, so that's why now here it's important to know your x coordinate of the turning point, your axis of symmetry, because you are going to judge using your equation of the axis of symmetry. You are going to judge which side is decreasing, judge which side is decreasing using your what? Your axis of symmetry. So that's why it's important to know the x coordinate of the turning point. So in this case, for instance, all right, this side that we are saying is the increasing side. If I was to write my answer, I would say, for which values of x is the function increasing for this function? I would say, what's my x equation of the axis of symmetry? It's x is equal to 0. So this side, all right, is where x is less than 0. This side. Okay. So my increase is happening where x is less than 0. Okay. So there's an argument that's happening, right, between whether the answer should be x is less than or equal to 0 or x is less than 0. Okay. Some mathematicians insist that it's x is less than 0, all right, because there in that point we are stationary, all right. Some mathematicians are insisting no, we should include the x is equal to 0 as well. So x should be less than or equal to 0. So amongst us as maths teachers, we accept any of these two. Whether you write this or that, you'll be marked correctly. So if they ask you for which values of x is the function increasing, and then you say x is less than 0, 100% correct. Or if you write x is less than or equal to 0, 100%. You will be marked right whether you write this or that, because the argument amongst maths high schoolers has not been resolved in that they are saying, no, this is the official right answer. No, we accept both answers. Okay, so I'm saying again, on this side we are increasing, guys. This side we are increasing. Okay, so this side is represented by what? This side is the side x is less than 0, or x is less than or equal to 0. This side is called that. Okay, x is less than or equal to 0. So if I'm writing my answer for which values of x is the function increasing, then my answer is x is less than or equal to 0. That's where I see my function increasing. Okay, so for which values of x is the function increasing, you can either say x is less than or equal to 0, or you can say x is less than 0. You are good. Next question, for which values of x is the function decreasing? Which side are we decreasing? So once again, we're looking at our x coordinate of the turning point, our axis of symmetry, x is equal to 0. Then which side is the function decreasing? The function is decreasing, obviously, where x is greater than 0, or you can say greater than or equal to 0. As I said, they accept both. That's where the function is decreasing. For which values of x is the function decreasing? We look at our axis of symmetry. This side of the axis of symmetry, that's where the function is decreasing. That side is called where x is greater than 0, or we can say where x is greater than or equal to 0. Okay. That's where the function is what? Is decreasing. Yeah, Mageba for life, like I said, amongst us as educators, okay, we have accepted both of these. Whether you say this or that, right? The argument continues, because there's an argument that some educators or some knowledgeable people that basically study the study functions have said that no, it can't be this one, it must be that one. And some people say no, it can't be this one, it's that one. So the argument is there amongst the educators, but for the sake of the learners, we basically then mark, whether the learner says this or that, we mark it correct. All right, we mark it correct. I understand what you are saying, and it has grounds for you saying what you are saying. All right, but like I said, for the learners, right, if they write this, 100% correct. If I ask for which values of x is the function decreasing, and the learner for this function says x is greater than 0, I mark him correct. If the learner says x is greater than or equal to 0, I mark him correct. Okay. If the question says for which values of x is the function increasing, and the learner says x is less than or equal to 0, I mark him correct. If the learner says x is less than 0, I mark him correct. So all in all, what I'm saying is, for the purpose of the learners being marked, and what we have basically decided to accept as educators within the high school framework, all right, if a learner is doing CAPS, will be writing the NCS exams, grade 12 NSC, then basically National Senior Certificate will accept either of the answers. Okay, then here, guys, for this one, same thing. If I asked for which values of x is the function decreasing, first thing I do is I look at the x value of the turning point. Then obviously this side is the decreasing side. So that would mean where x is what? Less than what? -7/2. Or you could write where x is less than or equal to -7/2. That's where the function is doing what? Decreasing. Okay, that's where the function is decreasing. Or where is the function increasing? Then once again, I look at the x value of the turning point. The function is increasing this side. So I would say where x is greater than -7/2. Or I could say where x is greater than or equal to -7/2. Okay. Okay, so yeah. Hopefully we all understand what we mean by for which values of x is the function increasing, which values of x is the function decreasing. Okay. All right, guys, that's it. That's basically it as far as what I wanted to cover for today as far as functions are concerned. I just wanted to do these game challenge questions as I had basically said you must do in the previous video, so that I can answer those and that there can be clarity on that. What I then do want to do now, I'm going to end this live. I'm going to end it, and I'm going to do a live session on how to find the equation of a parabola function. All right, I just want to end this live though. I'm going to come back just now. I want to do how to find the equation of a parabola function, and then maybe just other things as well related to parabola functions. So let me end this. Thank you so much for joining in. Really appreciate it. I'll be back very soon.